Hello. In a previous video, I showed you how to use a visual model to factor trinomials with all positive terms. In this video, I'm going to show you how to use the similar visual model to factor polynomials with both positive and negative terms. Okay, the first one we're going to look at is x squared plus 3x minus 10. So in this case, the constant term 10 is negative. That's going to change something a little bit. So as before, I'm going to draw just a little square to represent the x squared. So that's x by x. And then the minus 10, I'm going to need to create using intersecting blue and red lines because it's negative. Okay, so in this model, I'm using color to represent that. So I'm thinking about how could I break up a 10 into two different factors, and I can do that using 2 by 5. Okay, so think of this grid as I've got 5 lines vertically, positives, and 2 lines horizontally, so that's 5 by 2. And I've chosen to leave the top and the left-hand side because you can see if I extended my x squared square, those lines would be blue automatically. So I'm not coloring those in. All right, so my intersections, you can actually count those points, intersections of red and blue, I've got 10 of them. So that's negative 10. All right, so as we did in the previous model, I'm going to extend the vertical lines, so in this case they were blue, up towards the top of my grid, like that. And I'm going to extend my red lines, which were horizontal, off to the left. And so here's the result of that. I continue this one and this one. So what I get here is x squared as my squared term. I've got negative 10 as my constant term. And then you can see these bars are different colors. The bars are, I've got 5 positive bars and I've got 2 negative bars. So if you think about what that means, 5 positive x bars and 2 negative x bars. Those two together, when you combine those 5 minus 2, generates that 3x that we're looking for. So we've just verified that x squared plus 3x minus 10 factors out to, this was plus 5 and minus 2. Okay, let's do another one. X squared plus 2x minus 15. If I was being really careful, I would write that 15 in red. But okay, so again, just draw a little square to represent the x squared, x by x. I'm making it that small because I'm trying to conserve paper. You could make it larger, it doesn't make a difference because the x is a variable. All right, now I'm looking at the negative 15. I have to think about how could 15 be divided into 2 pieces. Not divided by 2, but divided into 2 factors. So 15 can be broken up into 3 times 5. And I need to generate a positive 2. So that means that the 5 has to be positive. 1, 2, 3, 4, 5, and 2. 5 times 3 is 15. And then just extend those lines. So I'm going to extend the x squared lines to box that in. I'm extending the blue verticals up, and I'm extending the red horizontals across. Okay, so I've got x plus 5 across the top here, and I've got x minus 3 down the side. So the factors of x squared plus 2x minus 15 are x plus 5, x minus 3. And you could verify if you counted your intersections that you've got 15 little units that are negative. You've got 3 negative bars and 5 positive bars, making 2 bars, and then x squared up in the corner. Pardon me. Okay, let's try another one. X squared plus x minus 12. So as I mentioned in the previous video, 12 is a number that is very divisible. It can be divided by 1, 2, 3, 4, and 6. So it has a lot of possibilities. So before I start drawing in pen here, I'm going to look at what's the term in the middle to give me a hint of what those two values have to be. The term in the middle has a coefficient of 1. I don't see it there. It isn't written because that's a time-saving thing. If the coefficient is 1, we don't bother writing it. So 1, so I'm looking for two factors with a difference of 1. That would be 3 and 4, but it's negative. So we're going to do this. Little box for the x squared. And then negative 12 is going to be 3 by 4. The 4 has to be positive. 1, 2, 3, 4. Lines that are 3 long. 1, 2, 3. So at this point, if you're looking at your intersections, you will see that you've got 12 little negative intersections, which are making that negative 12. And then at this point, I'm going to extend each of my lines. So I extend this one down to complete the rectangle. Extend the reds across and the blues up and down. There we go. Okay, so what we've got here is negative 12 in the units, x squared as the first term, and the bars in the middle, or on the top and the left here, are positive 4, negative 3. So my factors of x squared plus x minus 12 are x plus 4 and x minus 3. Okay, we're going to look at one more. This one's a little different because it's a binomial instead of a trinomial, but the process is actually the same. So I'm going to start with my little square for x squared, so x by x, and then minus 9 can be broken up into 3 times 3. So I'm going to go 1, 2, 3. It's got to be 3 long. Times 3. So there's my little blue and red grid that represents that minus 9. And now we're going to extend each of our lines. To complete it. So I see two things here. One is that this is filling a square space, and that my factors are x plus 3 across the top, because these were blue bars across the top, and x minus 3 along the left, because they were red bars along the left. So this is what's known as a difference of squares. Okay, just for a little bonus, we're going to do one more. All right, again a binomial. This time I've got 4x squared minus 16. So I'm going to start with making the 4x squared. And I know that that is something I can draw as a square, so I'm going to do that. So I've just drawn x squareds in a square that is 2x by 2x. So the dimension of the length of one side of that is 2x. My 16 is negative, so I'm going to have 16 can be broken up into 4 times 4. 4 lines high and 4 across. So that's my minus 16. And when I complete or continue those lines, blue down here, I'm going to have up top here, I've got 8x positives, and I've got 8 negative x's. So this is plus 4, and because these bars were negatives, it's negative 4. So my factored form of this binomial is 2x plus 4 and 2x minus 4. That one was a little trickier.